Okay, this is problem 4 of the linear regression quiz. And it says the Great Plains Railroad is interested in studying how fuel consumption is related to the number of rail cars for its trains on a certain route between Oklahoma City and Omaha. And the very first thing it says is write the regression equation. So I went ahead and input this data, and I put the number of rail cars, L1, and fuel consumption, L2. Because I personally believe that the number of rail cars impacts the fuel consumption. In other words, the more train cars we're pulling, the more fuel we're going to use. So I'm believing that X, this will be my X, and this will be my Y. So I'm thinking the number of fuel cars is going to help predict fuel consumption. So I've entered the data into the calculator, and the easiest thing to do at this point is just go stat test linear regression t-test. My data list is L1, L2. Keep this as a not equal. Alpha trace. Alpha in the trace button. Press enter and calculate. All right, so real quickly, I get my y-intercept and I get my slope. So my regression equation, oops, I want to get a red pen, is going to be y hat, make sure that that's a hat, equals 10.6767 plus 2.149x. Now, I always have to define this, all right? And so there's a couple ways. Another way I could have written this, and another way to have written this would have said fuel consumption and I'm going to put fuel, but I probably should say fuel consumption equals 10.6767 plus 2.149 number of cars. If I had done that, I wouldn't have to specifically define it, but I highly recommend it. So X equals the number of rail cars. Y equals the fuel consumption. Identify the slope. Well, we already know that this is a slope. It's positive, and I always start off by going, well, I remember change in y over the change in x. So in this case, positive 2.149 over 1. All right. So that means I basically have a positive, there is a .149 unit per mile. That's supposed to be an A. Unit per mile increase. Now, I know it's an increase because this is positive in fuel used for every one increase in the number of cars. Or you could set for every additional car in the train, okay? Identify the y-intercept and explain its meaning in context, all right? Well, our y-intercept equals 10.67. All right, that's our y-intercept. And in this case, our y-intercept says we would use this much fuel the train would use 10.67 units per mile of fuel if there were 0 rail cars. In other words, if it were just the engines, but you need to make sure that you say 0, all right? But in this particular case, if there were just the train engines, it would use 10.67 units per mile, or that's what we predict, if there were 0 rail cars. Write the coefficient and determination and explain its meaning in context. So we're looking for r squared. So I need to scroll down just a little bit. There's r squared. That's a very high r squared. So in this case, r squared, the coefficient of determination, is 0.967. So I can say 96.7% of the variation in Y, which in this case is in, you always need to put it in context, in fuel consumption can be explained by changes in the number of cars or number of rail cars. That means a little over 3% is caused by other factors, but 96.7% of the variation in fuel consumption can be explained by the changes in the number of rail cars. Write the correlation coefficient. Well, the correlation coefficient is just the square root of that, but the calculator actually gives us this. So the correlation, or R, equals 0.98. And notice R is positive, but so is our slope. They will always, the R and the slope will always have the same sign. If they don't, something went way, way wrong. Well, this is a very, very, very strong correlation, which means my data points should lie very close to the line. The stronger the relationship, the closer the data points are to the line. So there is a strong, which direction? Positive, linear relationship between the number of cars and the fuel consumption, all right? Or say, but the fuel consumption, and no, it doesn't matter the order, and the number of cars. So basically, there's a very strong relationship between Y and X, all right? Explain what S is in the context of this problem. S is 4.36. The standard deviation of the residuals is 4.36. All right. And so the standard deviation of the residuals measures the amount of variation in Y. In Y, amount of variation in Y for, or excuse me, I said Y, I should say in fuel consumed. So I always need to keep it in context for a given number of rail cars. All right, the standard deviation of the residuals is 4.36 and measures the amount of variation in fuel consumed for a given number of rail cars. Perfect. All right. I ran out of room, so I abbreviated. Please don't do that. Next thing says create a scatter plot for the data. Mainly, I just want to see that you can actually do this. So should go to y equals and clear everything out. All right. And then I have my data in the stat edit. I'm going to go to second stat plot. I should be on, off, off. So arrow to the left, press enter, make sure it's turned on, select the first graph. My X list is L1, my Y list is L2, press zoom 9. And we get this pretty good line. All right. Now we can use the trace features. We see that, okay, at X is 20 and 58. So I have one right here. Now I'm going to go ahead and rerun my test, stat test, linear regression t-test. And I'm going to store my equation this way I can see my line. So I think it's going to help me out in my drawing. And now I'm going to press zoom 9. And there's my line. All right. So go back to that trace. That's at 58. And the next one is at 52. So both of these are, this is here, this is here. So my line is coming like this. And I notice I didn't go all the way down. And then I end up with going all the way up. When I get over, when I look at my data, I go 50, that's 122, and that's the highest one. So at 50, I have one up here. And so I'm going to end up with a line, according to this, that looks something, well, that's not very good, but something like that. And I'm just going to go ahead and fill in those points using my trace feature. So, oops. And so we have our trace feature, and I'm just going to kind of give these in here quickly. Don't tell the teacher I did it like that. So that's pretty close to what we had. So that's pretty close to something like that. And if you notice the relative distance to the line, those data points are really close to that line relatively, okay? All right, so that's a pretty good, and I should be labeling this, I should be labeling my X and Y. This is fuel consumed. I should have done that already, labeled that fuel consumed. And this is going to be rail cars, number of cars. All right. This is going to be centered at 0 because this is going to be my residual plot. And these are my residuals. And down here, this is the X direction. So these are my number of cars. And what I'm looking for is a random plot. So I have to do my residuals. So I'm going to go to stat edit, go to the top of L3. And then I'm going to press the second button, followed by the list button or the stat button. I'm going to scroll down until the word residual comes up. There it is, resid. Press enter. Enter again, it gives me our residuals. Now I'm going to second stat plot, enter. And I need to change this to an L3. Zoom 9. And there it is. And so you see that I have one up here somewhere, one down here, a little here, a little there, a little closer, here, and here, and here, something like that. Then I need to add one here and another one here. Now I look at that, and there might actually be a pattern, all right? It's pretty random. It's pretty random. It's pretty random, but there could be a pattern. There might be a pattern here. I don't know. I would like to have more data points. But anyway, the main thing is that I wanted you to be able to see whether or not, of course, maybe my drawing is off a bit too. This data point needs to be higher. But that kind of gives you an idea. And by the way, if you wanted more exact, you can use the trace feature and it'll gradually get around to everything, but it doesn't go in order and that kind of stinks. All right. So that's how you do this, and good luck. Thank you.